start with the recording.
Yeah. Okay. So, good morning, everyone, and welcome to MuleSoft Mysore Meetup group. So today we will be introducing you to a very common integration patterns used in MuleSoft, and we'll see what all are the integration patterns available and what all are the components available in MuleSoft, and how we can make use of all this in our integration area. And today we have our speaker Robin Sharma present here, who would be speaking on this topic in a while. But before that, let me introduce you all to the organizers. So I'll just start with myself. So hello everyone, my name is Priya Shah, and I'm currently working with LTI Mindtree as a senior software specialist. So it's been 5 years since I'm started working into the integration area, and I'm IBM and MuleSoft certified. I'm also MuleSoft mentor and meetup leader of Kolkata. So we have two organizers, Shubham and Giridhar as well. They are the meetup leader of Mysore. Giri is not present here today, so I'll just introduce about Shubham. So he's an ambassador and he's currently working with Bilinium as an integration developer. So that's all about the organizer. I'll hand it over to Robin to start its presentation. So, Robin, you can share your screen and start.
Sure, Priya, thanks. Just let me know when it's visible.
Yeah,
Yes.
Robin.
Okay. I'm not sure. Whenever I'm hiding, it's okay. Is it visible now? The screen?
Yeah, it is visible and is
Yeah.
maximized.
Okay. So hey everyone, let me introduce myself again. I'm Robin Sinha. I'm working as a specialist too in Hashin by Deloitte. I have almost around 3 years of experience in integration now. I'm MuleSoft certified as an integration architect as well as a developer. I'm also certified in which is like basic certification, but in and also certified in GCP. So in GCP, I'm certified as an associate engineer as well as a GCP professional architect. So me, so today we'll be covering the doing the puzzle integration patterns decoded. Basically, we'll touch upon all the integration types and what are the pros and what are the cons, as well as the real life scenarios examples like we do it in our daily life, and as well as in terms of MuleSoft. So basically, first things, whenever an architect thinks about before designing any solution to any given problem, so the thing is they have to decide, they have to take decision. This decision has to be like start at starting only, so while designing the solution. So that's a question. It should be synchronous solution or it should be async solution. So I'll try to keep this session interactive, so any one of you who knows the difference between a synchronous solution as and asynchronous solution. And why should we use them? Anyone from the meetup want to share something?
Synchronous is used for sequentially, and asynchronous is used for parallel processing.
Okay. Anything
Yeah,
more?
I think synchronous works basically in request reply pattern, and asynchronous is something where we request but we do not wait for reply. So
Okay. Yeah. So both have pros and cons of its own. Sometimes we go with synchronous and sometimes we go with asynchronous. So let's first take deep dive in synchronous. So this approach is mostly used when we need the reliability is more important than the processing part. So the reliability means that we need this answer just not in near real time but in actually real time. So you request and you want the response. You don't want to wait for it, like basically you don't want to check for it afterwards. You'll have until and unless the solution is in your hand or not, the answer is in your hand or not. So basically synchronous solution integration is a real time data exchange. The systems like communicate, like communicate directly and expect an immediate response. So for example, the real time example, for example, all the UI lookups in your websites or in your applications, if you're using WhatsApp or you're using basically Instagram, and you're making a get call, basically you are searching for some username. So you will wait and you want the response in your screen that time only, and you won't need a solution where you will search for it and after 5 minutes you will get the response saying that notification, okay, we found your username. It happens in some big data query, but in the real UI lookup call we need the real time response. No matter if you want to make it asynchronous, it's still a problem. So this was one of the synchronous solution where we had to go for synchronous. So let's go for the, synchronous little quickly. So after the flow receives messages, all processing including the processing of the response, and it's on the same thread. The flow needs to meet the requirement of the transactional processing. So basically transactional processing is nothing like end to end processing, and anything goes wrong, it also gives the feature of rollback. And processing also means that the first event starts and ends as the same event. Not in the async, first event starts and ends, but the other events like the threads are copied like a multiple threads, and those runs simultaneously. So the flow's inbound endpoint must be notified about all the errors that occurs during the processing of the message. So let's take this example and understand what is basically synchronous, how it works. So for example, if any I get a and like get a hit on my endpoint, I'll go to process a makes another request, basically another get call to some other system. Now what synchronous will do, will the event will wait. So basically event will wait here in the second block unless and until this block B is completed or not. It will wait for the response of this block B will come back, and then if there are no errors, the actual solution is there, and we get the success response, then only it will go to block B, C and D. It it makes a delay, but still we get a reliability that flow B ran successfully and completed the path successfully. So that's it's more reliable. Again, in the terms of error handling, you can always propagate back the error to the calling system, and that is not possible in asynchronous. In synchronous, you can always handle the errors accordingly in the calling system. So for example, you you can just have one experience API. So if you are going with API led connectivity, we have one experience API, we have one process API, and the one system API. So any errors in the system API, you can have again send back to the experience API and handle error, do the error handling there. Use DLQs, use error queues according to you, use circuit breaker, and then you can just reprocess or publish the errors accordingly. It's upon to like a problem to problem and solution to differ solution to solution, but it gives you an upper hand to get the errors back, but that cannot be done in asynchronous. So just an example. So uh, just in the real life scenarios, any one of you can tell me like what is the most used process, asynchronous or synchronous? Any one of you, it's a real life. So for example, in the real life scenarios, what is the most common thing apart from MuleSoft, like in the daily day to day daily life we live? So what processes are most common, synchronous or asynchronous?
I feel it's synchronous.
Synchronous. Okay. Anyone else? Okay. So the answer is the world runs on asynchronous processes, never synchronous. Each and every process, be it in your mobile phone, the CPU, how that is working, everything, your operating system, everything works on asynchronous. We never work on synchronous because there is a limitation for synchronous. We cannot scale, we cannot, it's increased complexity because in asynchronous again you are waiting for the errors, you are waiting for the positive response. It's not fire and forget. You'll have to wait, you have to check all the conditions. It also blocks the resource. So for example, unless and until your the target system, so we have experience API, source system, experience API, process API, system API, and the target system. If you're making a synchronous call, your source system is waiting for the response of the target system. Until then that event is like almost blocked, so that is resource blocking. So we don't use synchronous. Coming back to the real life example, all the managers, right? If architectures, all the basically seniors, how they do a synchronous process, I'll like indirectly they follow asynchronous process only. They will connect in a DACU call and they will assign the task, and they will roll off from the call and they will do some different tasks throughout the day. And it's on the developers or on the team's responsibility to complete that task. So this again is an asynchronous process if you look at closely. Now the SA or the architect or the manager is not waiting for the team to complete the task and then only they will do those things that they want the report in this call only. They will make them work, and only when it's very priority, that's the time. It's like they want it now only, it needs to be done, and the manager wants to be sure that the report is correct under their eyes. That is a synchronous process. But when a manager or the tech architect just goes to another work and the development team or the team is working on the other thing, again they make it asynchronous because it's not possible for any process to run without like to run loose coupled in synchronous processes. So that's why we make it async. So the limitations we added, that it's like scalability is very limited, it's the complexity is increased, and it's also have resource blocks. Let's go to the asynchronous part. So it says embracing delays, in asynchronous integration patterns. Now why we use it? Anyone? So I already covered most of the part why we use it while explaining synchronous processes. But again, why we any architect will go for async integration patterns? What should be the simple answer whenever they are choosing? So for example, you are designing your application. So instead of going real time, why you will go a near real time approach, or like a asynchronous, basically independent process approach? So what should be the key factor deciding this asynchronous integration patterns?
Robin, I think when we don't require the response back, then we will go for asynchronous.
This can be one.
And for time consuming tasks, like if we want to process the data parallelly, and there will be no dependency with the main process.
Okay. So the
If
simple
there is
answer
a
is,
manual
yeah.
process or manual task behind the scene.
Okay. So
We also want to decrease the load of support members. We want
okay.
it to be independent.
Okay. So Actually, all these answers are correct, but when the most important thing is the answer was, like, I think already one of the person said that when you don't need a real time response, that's it. You can go for, always go for asynchronous process, like integration patterns or designs. All those answers, the other answers are also correct, but it's the weightage of the answer is like, even if you have manual processing everything, but if you need a real time response, you'll still have to go for the synchronous job, and you need to modify your approach as to accommodate with the synchronous answer. So for example, if it is UI lookup, and if you're looking into a very big table, still you will have to make it synchronous, because your UI will need the response within an SLA. So like 3 seconds, 5 seconds, depends system to system, but you will have to go for the synchronous approach. But if you don't need the response in the real time, you can just fire and forget. So this fire and forget is something that you call a system and you send the response. It can happen that it will error out, then you will have to handle that error accordingly, but the source system doesn't care. That is what we say, that it's not, they don't need a real-time response. So let's go for the asynchronous approach. Asynchronous approach gives us flexibility. It is less complex. We can scale. So for example, there are so many types of asynchronous integration patterns: pub sub, hub to spoke, message broking. They are like batch integrations. All are type of asynchronous integration patterns, and it gives us scalability. So for example, pub sub or hub to spoke. Hub to spoke is something like you just send the data to hub. We call it topic exchange in MQ, and from there you can bound n numbers of queues, and anything you send to hub, the hub can send those to all the queues at the time, and all those queues can be subscribed in each other process APIs or any XN APIs, and from there you can manage. So for example, you had one message from source system, for example, let's call it Oracle, and it got distributed into n messages. So this was hub to spoke, and this was achieved due to asynchronous, because we didn't want, the source system doesn't want any response. So what are the cons? Can someone tell me what are the cons of this asynchronous approach, apart from not being real time, like not being the real time answers? Anyone? What are the cons of this asynchronous integration patterns? Like, we already know that it's not real time, it will go, like we won't get a response, but in this case, a source system doesn't need a response. So still, while going for this approach, what other things an architect should take into his mind before actually implementing this solution? What he should make that it should be proper, basically? Anyone?
Reliability.
Okay, reliability one.
Reusability.
Reusability, I think it offers more reusability than synchronous. It is because it is loose coupled, so I think it's not a con, but it's a pro. So apart from in that, these anything?
Performance.
Performance are actually more in asynchronous integrations. So these are the pros. I want the cons, like what the architect should take in mind and make, like, basically while making this design work, what should they think, that be aware of that, okay, these are the challenges which can come, so let's focus in the initial phase only. So those are the basically challenges we face in asynchronous integration patterns.
It can be time consuming and might not get the reply back. We might lose what we have requested.
Yes, this is one. So basically, asynchronous integrations are not reliable. there is a chance of message dropping, message losing. So for example, you have a total control in your hand in synchronous approaches. You deal with it at that moment only. Basically, a challenge comes, a request comes, we will call it a challenge here. You will take that challenge, you'll go to everything, you'll reprocess, you will basically not reprocess, you will handle it at that. If something goes wrong, you'll handle, and at least you'll tell the source system, okay, this failed, we cannot do this because this system x system, like you'll propagate the actual error back to the source system. But in asynchronous, there's nothing such way. So for example, the challenge is, if you send it, once you send it to queue, the source system won't know if that message actually reached the target. So for example, let's take example of a email communication, right? So for example, you go to Pantaloons or any XYZ mart, you go, you buy some things, and they ask that, do you want an invoice for it? You say yes. Then they again, they make a question that you want an email invoice for it, and you say yes. So they don't want a synchronous call there, because they don't need that the actual email like went to you or not. So what they will do, they will make a queue based system. They will process it, take my data, take my customer data, take my billing data, and then send it to the, for example, some SMS or email systems, for example, Salesforce. And then Salesforce will again queue it and then process it accordingly in their template, so that each, because each company will have a different template, and then send me the actual email or the SMS. But the question is, the POS, let's call it Oracle, the POS is like the point of sale, the computer they have, will never know that I got the email or not, right? So this is the problem of asynchronous integrations. Again, the latency, sometimes the queues can get delayed, there are so many messages can queue up in the queues, and then it can take hours, right? So for example, if I'm waiting for an urgent email, for example, I need that email at that time, I requested him, I'll have to wait for n minutes, and that n minutes can be upon the systems involved. So this is latency. The third is ordering challenge. So for some example, let's take an example of, if you have made an inventory system, right? A queue based inventory system, asynchronous. So the ordering is also the challenge. Sometimes the message will be fetched before, so you can implement a FIFO, but again, FIFOs make it more slow. So an ordering challenge, so you cannot control the messages. For example, if you are using hub to spoke, it goes to the different system, but you cannot control that which system subscribe it first. For example, it can be the sum of the requirements can be in such a way that I want X data, then only Y data. It happens most of the time. I cannot have Y data before X data. So in queue system, it's very hard to maintain if the systems are different. So let's go back to the inventory example. So at 5 hours, we had 10 pieces of cloth. Let's take an example, like 10 pieces of Maggie. I sent to update the target system that I have 5 pieces of Maggie at 10 p.m. At 10 a.m., those four Maggie was sold. So now only I have one piece. And again, update the system. I have one piece of Maggie left at 10:01. So the order, for example, if you don't take the timestamp into accommodation, because timestamps, the source system not can always take timestamp into the account while arranging it. They will just need updates per second, so like just tell me what's the current update. So if you remove the time from the logic, so it will have just 5, value 5 and value 1. Now suppose that in the queue system it got interchanged, so that the latest value will be 5 instead of 1, because but our latest value was, earlier it was 5, 4 got sold, now it is 1. But in the actual target system, the message reached in the interchange form, so we will say that we had 1, now we have 5, which is a wrong data. So it's a very big challenge in ordering in asynchronous. Most of us faces them, and we'll have to check if we can resolve them using timestamps or using anything else. You can use a staging area, SFTP, to stage in the sequence and then take it again. So all those challenges, These are the ones which architect will have to think about before actually implementing this. So in MuleSoft, we have async scope for the the minimalist approach. We can directly use the async approach. So what it helps, so for example, if a process comes here, use a scope, it will also go ahead, it will divide the event into two threads. So one event into two events. So a mule event will come from here, it will go. So for example, this async scope is also there in batch. So as soon as you implement a batch processing, it will come to A, it will feed the data to batch, it will go to B, C, D, E, and then it will finish F. Now the batch is like, for example, a generator. You go open the generator and you go to your home, and that generator starts processing message. It can take 2 hours, it can take 1 hour, it can take n minutes, depending upon the task you gave. And when it will end, when it will get finished, it will again get finished. Like basically this event is not, does not care of this event, it is independent. So it gives us like a power of not waiting for it. So for example, a manager comes, gives the details to the team, and then just goes to the another call. Starts processing a message, works along for 2 or 3 days like a sprint, and then develops and gives the actual like the application or the product. So this is async process. So most of, that's why I told you, the most of the time in the real world asynchronous processes happens. So let's see how to achieve. So async scope is one of the options, scheduler, a subscriber, message broker, and trigger based events on rate, on row, like on new, on update. So a question here, what is the difference between a scheduler, subscriber, and on update and on new? Any one of you knows there what's the difference between those two?
On new and on table are event based, and
Okay.
scheduler is time based.
Okay, subscriber is also event based. When you do polling, every 2 seconds you poll or you do prefetch, it keeps the 30 message, like the default 30 message in your local. So what's the different, how, what is the mechanism different working in both of them?
So the timer will be idle until its frequency uh, comes. Like for other events, it will be constantly polling for the event.
Okay. Okay, so the better answer to this is, it's for example, what happened in earlier times, the back end always, sorry, the front end always tried to check, okay, do I have a message, do I have a message. For example, this is polling. So every 2 seconds what we are doing, we are checking, we are hitting, okay, do, for example, it's like a person who is very eager that did the parcel alive, and they're just knocking every 2 seconds that, okay, did my post arrive, did my post arrive, just to check if the post is there or not. But this is a very tedious process, and in the actual front end and back end, for example your WhatsApp, it will consume so many threads basically. And if you take the actual users of the WhatsApp, it's not very practical to do that. So every person will start hitting backend, their backend servers, and to check if the message is there, if they have received the message or not. So for this they have implemented webhooks. Now webhooks or on update works in a similar manner. The backend is not concerned. For example, if you use on update, MuleSoft is not concerned about, basically your application is not like knocking every second or every 2 seconds to check if the message is not there. The basically the target or the backend, if you say like itself, like basically the backend itself will tell the front end. For example, for now let's consider MuleSoft as a front end. because, and the target, the actual target as a backend, just to make more clarity. So now the backend will only tell, okay, I have a message for you, which makes more sense. So example, in WhatsApp, your 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 application is not calling every time your backend. Your backend is saying, okay, so that is on update, and there is called webhooks, that we have a message for you, and now you receive that message. So in same way, on update, on any event. So the, for example, if it's a Salesforce, so that's why on update, on new, all those are like system to system. So you will have on update, on new in for Salesforce, on update, on new for Excel. So every file, so you will have on update, on new, because it's sitting in your, basically file will tell you that, okay, I have your file system, or your Salesforce system will tell you that, okay, I have a new object, I have a new file, like I have an update, just check it. Now your application will get that. So that is on update, and difference between a subscriber and on update. So this on update or on new, on table, all works in the same way. So in the event processing, we have two like messaging models. We have point to point and pubs up. Anyone quickly can give me difference between point to point and pubs up? Okay. So basically, point to point is a straightforward setup. It allows the direct connection between the two systems, basically. So one point, the name describes it. One point, the second point. The problem with it is like we don't use it mainly, but it is this stability issues again, because we are making it so hard coupled. We cannot reuse as much as we can use pubs up. And again, if one system fails, the other system which is connected to it again will get issues. So you'll have to handle it that way. Now coming to pubs up, it's the most common asynchronous way of messaging we use. PubSub is also like provided by MuleSoft from MQ, and you can also do this from JMS message broking. It's the same thing, but again, there the broker is there, and in MQ everything is managed by MuleSoft. So let's go to the Java messaging service. Again, what happens in the Java, MuleSoft allows us to connect with MQ brokers from JMS. Now what will they will do, we can use to create, receive, send and read message, and also exchange message between different systems. So it's example that some enterprises application may have n number systems, and they exist in different location, they use different platform, they want to exchange information in a loosely coupled manner, then we should use JMS message system. So there's a JMS message system, there are different systems or servers, and we'll publish it to JMS. Now JMS broker will decide which is getting subscribed, and accordingly it will distribute the message. So component 1, component 2, queue and the messages. So again, point to point is like one message delivered to one receiver only. Queue is used as a like a middleware, MAM, but again it's very limited use, because so what this offers is a security, because only one system is connected to the other, so it won't allow all the systems to communicate. It just like we fix it, okay, this system will send the message. So for example, syncing your database to POS to database. For example, if you have a POS, Oracle point of sale, and you are making in sale, you want it in your system, you can do a direct call, any update, or you can just implement a queue if the transactions are so much, and it's just one system and there are so many POS, because in one store there can be 5 POS. For example, in all over India there can be n number of to one master database. So you can use queue based. So to post the transactions, we call it post transaction, we call it post logs. You can just send it, and your, so this is point to point. Again, it is very, you can maintain the security very much, but again it's not very like, it's very tightly coupled. So if your your database is down, your all messages will start failing. So it's just client one sends message, queue, clients two send, consumes, and acknowledge. That's it. So this is point to point. Now again, PubSub is like you use a topic or exchange as like hub to spoke. So you send to a topic, and all the queues which are bound to it will get the messages. Let's go to other. So some of the common integration architecture: point to point, hub and spoke, publish and subscribe, message broking, API gateway integration. Again, API get the REST calls, batch integration, file based integration, microservices integration, enterprise application integration, and service oriented architecture. So I think the top 8, I think it's very common. Let's go to last. So microservices, enterprise, and service oriented. Just a second, I need some water. Okay, so till here, before we go to microservice, enterprise, and service oriented, any confusion, any questions regarding any of the topic? Okay, so this microservice integration, we can use both synchronous and asynchronous way. It depends upon the communication mechanism we use. For example, between the microservices, so if you use RESTful calls, it can be synchronous. You can also implement event driven communications, which are asynchronous. So this, and the second is enterprise application. So these microservice integrations are basically between the two when the two microservices needs to communicate with each other, we implement this. Now enterprise application integration, again it, so all this, the below three can be again synchronous as well as asynchronous, depending upon the needs. So if you use RESTful calls, directly get calls, it's synchronous. And if you use any queue or event like trigger based, then it's asynchronous. Now this service oriented architecture, like we call it SOA, again supports both, and it communicates within the interfaces. So it's not a UI call, basically it's not the user interacting with each other. So if a user interacts with a UI, they should be always synchronous, because they need the data as soon as they send. Okay, so it's about all about SLA. It is 3 seconds, it is 5 seconds, so you can never go for asynchronous way. You'll always have to use a synchronous way. But sometimes the interfaces also, like specific service interfaces also communicate with each other, so that's completely fine. That is completely, you can always have a asynchronous way to communicate with each other. So yeah, let's take an example. So for example, it's a asynchronous versus synchronous. So we already know the time is less, like in async. When, how? So we, for now we are talking like all the time. Okay, let's go back. So can you tell me the scenario where async will take less time than synchronous? Any one of you?
When the load is high, too high.
Load is too high, then async will take less time to process.
Yeah.
Okay, so just tell me, just one more question: is scatter gather async or sync? Like basically synchronous process or asynchronous process?
It's still synchronous.
Yes, it is synchronous because at the end of it, it will divide the events in the async way. Like it will divide independent events and they can run in the async way, but it makes it synchronous when it waits at the endpoint. Basically, when it is ending, it will wait for every process to end. So that's why it will. So for example, if you're sending one point and then it's dividing into three, when it come back here, like a diamond structure, when it will come back here, it will wait for every part to get completed. That's why it's a synchronous in nature. So coming back to the original question, async will only give less time when you are doing multiple calls at the same time. For example, when you are for just check example to create a card. So why async in creating cards? So that's why let's take a real life example. When you go to Amazon, you create a cart, right? When you buy five things, you create a cart. That cart is a temporary basket. You keep your things there. So how we will use async there? What Whenever you are clicking on buy now, there should be two things. One, the order punch part, and the second, the delete basket part, right? So we don't need that cart anymore. You won't see any cart. So when and like as soon as you click on buy now, you will see that when you are going to the payment portal, if you complete your payment, the cart is gone. And if you don't complete it, your payment fails or something rollback happens and your cart is still there. You'll see that at five items, you won't lose the cart, but you will lose the cart as soon as you complete the payment and everything happens fine. So there we are using async process. At the same time, we are keep taking you to the buy now portal. Like when you click on buy now, two things happen. At the same time, we punch the order in the back end. We wait for the payment confirmation, and like as soon as the payment confirmation is that the payment is successful, we complete the order at the back end. And at the same time, we also quickly deletes your basket or cart. So that is a async process. But if you want to make it a synchronous, it will take more time. So similarly in this thing, what they are doing in, so they are calling checking products, then checking customers, mapping, and then making orders. So these are three independent major processes which happens in any retail. So product, customer, and orders. What now async is doing, they're searching for products, mapping the customer, like searching for the customer at the same time, then mapping, and then creating the orders for them. Now what will happen, as we search for the customer and products at the same time, like we example, it's about divide and conquer. So for example, like a manager gave you a task in your project, went to the other call, gave the task, and then so you two projects work simultaneously that day. So the overall achievement was much more than if you would have done like first he waited for your work completion and then went to the other project and again waited for their work completion. So again, this is how the real actual world works. And then the placing orders, because we have both the data, we get the gain. That's why it makes asynchronous faster in these cases when you're doing multiple calls at the same time, dividing events into two or even three. But again, the problem is it's not reliable. If this product fails, the customer will won't know that the customer process, that product process failed. Will have to roll back, again check. So this is completely independent upon of each other. So we already discussed many business use cases, the Amazon. Let's focus on one more business use case, which is email communications. So in let's take the challenges. What happens? So let's take the example of PubSub, and let's take the example of real time call. So an Oracle based POS, a point of sale, our customer needs an invoice on their email, they request the system. Now it's a real time call. Now there are so many systems involved. So first it will go to uh, basically subscriber management or customer management portal, that where this customer's email address is, or what is this customer already a part of it. It will get the data, it will get the address, everything from there. Again, it will take that consent part. There's a consent management system that is, if they have opted for an email, take that data, merge it, again send to the main target system. It can be anything. For now, let's take it marketing cloud. So it will send the marketing cloud. Till then our POS is waiting, right? It's a real time call. Now it will make the loophole. Somehow the system is, for example, some of the system, it's okay, so you can not always implement synchronous. If you're implementing synchronous, each and every system, there is also a fallback. Each and every system should be synchronous. For our example, the Salesforce marketing cloud is asynchronous. They are queue based. So there is no point in implementing synchronous, because in the target system, when you send any request, they will say it's queued and they will get the acknowledgement number. It doesn't mean that the actual message got processed, just it will send anything, you will send, it will say queued. So it's no point in implementing a synchronous solution there, a REST API solution there, because what we are sending back to the POS is the acknowledgement key, which doesn't guarantee that it's actually processed, or the actually end user, the customer, got the mail or not. So for synchronous, there is also a need that every system should be synchronous. Any of the system is async in between, then the overall idea of making it more reliable fails, and it doesn't even matter if you make it asynchronous. So why not? Now let's take the consideration of the second part, which is asynchronous. So he POS system send. So for example, okay, let's go back and make it a synchronous system. Let's make is Salesforce system as well as synchronous. So it will send the data to Salesforce, and Salesforce will process it quickly and then send the email to the customer, and then send back the positive response 200 to the source system, which is POS. Okay, the customer got email. The customer will check that, okay, I got the email, thank you. The problem here is the time. POS is a very busy area. People are waiting beside you, right? So you cannot give 5 minutes to one customer. So it's all about SLA and the contact. Like you only have 3 seconds to process all this data, because each system will take at least 1 to 2 seconds to overall response, like get the call and the response part. The request and response will at least take 2 seconds. Even if you make it faster, at least it will take 1 second. So 1111, it will add up to 10 seconds, which is against our SLA. And sometimes it will add up to 5 or 6 minutes, the total call. Let's be real. In the real world, it will take 5 to 6 minutes to complete all the calls. And then when you go back, it's too late. One customer cannot leave that. It's a line and you cannot wait for one customer. So now you'll make it async, the second approach. Now, async, what we'll do, whenever a request is there, we'll take it the request, MuleSoft, in our internal queue, and then process it, get the data, everything, and then send it to the SFMC queue. SFMC is Salesforce Marketing Cloud queue. The queue will again decide if the data is everything MuleSoft sent is accurate or not. If not, it will fail. So again, it's either like it's not reliable. MuleSoft will never know that the actual customer got the mail or not. But again, if it everything passes, it will again send the actual mail to customer. The customer will get mail in around 2 to 3 minutes. Sometime it can take 5 to 10 minutes. But again, according to our need, the data was processed. The communication will be in the large number. So for example, if it's a newsletters, if it's like a marketing event, it will send the emails in the large messages. So even if 1 or 2 messages get lost, it's still fine for the source system, because they are targeting lakhs of customers. So that is why it's tough decision, and it's a decision of an architect, or a, like whoever is designing that application will have to decide to go with the async approach or to go with the sync approach, depending upon all the weightage, what you need to be thinking about more. It should be more reliable, or it should be uh, more easy or flexible to process the data. So any questions? Anyone want to share something from their end, from their past projects? Anyone? Okay. Then I think
So
we are
Robin,
good.
you that at the end that some of the points regarding the factors which will help to determine whether the integration needs to be synchronous or async. So it is like more reliable, and you mentioned some of those. What are those, please?
Yeah. So for example, it's you need to cover so many points while actually building a solution, but the most important, the weightage should go to the reliability part. So if you need a reliable solution, a quick solution, then you should go for the synchronous. Basically we call it real time. And if you want a near, if it is okay for you, your system can work in near real time, or like basically they don't fire and forget part, then you can go for the asynchronous. These are the most weightage when you are considering any solution. As a sub part comes as a basically the second thoughts. Okay, when you're, if I decided to go with asynchronous, what other baggage it comes with? So we'll have to take consideration to that if your solution or if your systems works and can handle those baggages, if it can handle well, and if you can walk around, or like if you face some difficulties, you can have some workarounds, and if it handles everything well, you can just go with the solution. So again, async solution also offers 5 or 6 types of solutions. You can check each of them advantages and cons, and then select the asynchronous solution like that. The sync solutions are less, but again, the sync solutions are more often used when you need the actual response at that moment. The system needs to wait. Then you, if your system is ready to wait, for example, if it's more important to a person to get the email than a queue waiting in the shop. So it depends, right? It depends upon how important the call is. So if you need to implement that, yeah, you can go for synchronous as well. So for banking, right? So banking, if you're implementing a solution, any transactions, you will have to have transactions, right? Anything which is updated in your ATM should be updated in your, like atomicity we call it, and consistency we call it. So every time the data should be there. So there you can have synchronous calls. A system can wait for another system to get updated. And if you're making a queue base, then you have to make it more reliable. If something fails in queue based, so for example in SFMC, the marketing cloud fails to send the email somehow, they should have they should take that authority, or they should take that call to again inform the source system. So we are doing that actually in some of the solution. For example, submit order is nothing like a customer order for delivery. If your a POS is making an order, there's async call. If it's failing in the target system, it's target system responsibility to actually send a different request to source system, informing, it can be a message, it can be an email, to the source system that okay, your request at 5 p.m. or like this with order ID or order number failed. You may retry, there are your options there. You may retry the request, or you can have some other, like make a new order. So this is an architect will have to take care. Okay, anyone else? Okay, Shubham, I think we are good. So
Okay, I'll stop the recording first.